Welcome to Amplify the Hacker, offensive AI plugin development. I'm not going to lie, I was initially worried that AI might make me redundant, but I quickly realized it can augment my skills and help me become a better hacker, and save some time handling all the boring stuff. Today I'm going to share with you my journey with AI, and I hope to inspire you to create your own Burp AI extensions. I'll begin by sharing my first experiment, then I'll walk through the extensions I built and the key lessons I learned along the way. After that, I'll offer some practical advice on how you can build your own, and finally, I'll wrap up with the key takeaways. My first experiment with AI was to create a custom GPT that used the XSS cheat sheet as training data. I called it Virtual XSS Gareth. By the way, this isn't a substitute for the real Gareth. I have hands, I drink coffee, and I have an unhealthy obsession with XSS. This was a pivotal moment with me. I was genuinely surprised how quickly the AI could be trained, not only to produce sophisticated XSS vectors, and not only did it craft a working payload, but it also gave a clear explanation of how and why it worked. That was the moment I truly grasped the potential of AI. It left me excited, but a little unsettled. I knew I had to find out more. To kick off, I'm going to walk you through how I integrated AI capabilities into Hackverter. In this video, I demonstrate a request containing hex escape data in the query parameter. I select Learn from this request in the context menu. Hackverter sends this information to the AI for analysis. The AI identifies the encoding and generates Python tags. And then once learned, these transformations can be used without consuming any additional credits. While hex escapes are used in this example, any encoding that the AI understands is supported. So have you found yourself in Repeater decoding, editing, and re-encoding it and then sending it? Hackverter solves this problem with editable tags. You can place them around with what you want to edit, much like HTML, and Hackverter will dynamically encode the text as you send the request in Repeater, allowing you to quickly edit and repeat. Advanced users can write custom tags with AI, Python, JavaScript, Java, Groovy to extend Hackverter's capabilities. Here are the key features I added. The first I've already demonstrated in Repeater. The second, we have summarized custom code tags. Whenever a custom tag is created, Hackverter will use the AI to summarize the behavior, making it easy to understand, audit, and share. After that, we have AI-driven custom tags. You can create a tag powered by natural language prompts. Just describe what you want it to do, and the AI will do the rest. And finally, you can generate code from a prompt, just provide a few examples and describe what you want it to do, and Hackverter will write the tag for you. This is a good illustration of AI-driven tags. So in this video, I'm using AI-driven tags to crack an MD5 hash. You'll notice that Hackverter prevents you from executing the tag on every keystroke. It successfully recognizes the hash, and because the AI has already observed it in its training data, the whole process consumed only one Burp AI credit and provides a good illustration of how you can use AI in Hackverter to do cool things. So here, this tag, you can just embed your own commands. So it's a hash. You can embed the prompt within the tag. I tell it to crack the hash. Hackverter prevents the keystroke causing an AI request every keystroke, and then you can crack the hash. So the problem with this is indirect prompt injection in the request. So to mitigate this, the agent processes the request as inline JSON and detects and interprets the encodings within the address, within the request. Then constructs custom Python tags to handle the encoding and decoding operations. I give the agents contextual identities such as you're a web security expert, or you're a Python expert, and this helps improve the AI's responses. It's a two-step process. The first agent detects the encoding and then generates a conversion prompt, which is then passed to the second agent, which produces the final Python code. Hackverter can analyze the entire request to identify the encoding used, or it can focus on specific parts instead. You can configure it to automatically detect encodings and generate relevant tags each time a certain number of requests are sent in repeater. I use a HTTP listener combined with request diffing to detect changes, which allows me to isolate only the changes and send those to the AI. Here's what the prompt looks like. So I can't show you all the prompts, so I've just made them as concise as I can, but there's obviously a lot more to this. So the initial prompt tells the agent to generate a prompt which handles both the encoding and decoding of the data. I also instruct it to include basic tests to verify the functionality. At the time I wrote this, the test typically led to more accurate and reliable outputs. The second agent is responsible for generating the Python code. It receives a tag name, a list of tests from the first agent. Initially, I separated them because I wrote this code about a year ago, and the AI struggled with prompts that required multiple operations. With today's model's improvements, this could likely be handled by a single agent. The communication between agents is done using inline JSON to pass the prompt name and associated tests. I designed it this way to avoid indirect prompt injection in the actual request because it's generating Python. So maybe you can hack it, give it a go. It's good fun. Nobody has managed to do it yet, so give it a shot. Temperature controls how creative the AI is. You can use lower temperatures to produce more consistent responses. Use higher temperatures when you want the AI to be more creative, such as writing descriptions. I'll give you a little example about temperature. So I asked the AI to generate a new Hackverter tag name. I gave it a list of the existing ones and told it not to create duplicates. I cranked up the temperature for creativity, and that was a rookie mistake. I tested it with Unicode Escape, and it nailed it. Unicode Escape, great. Tried it again, and it detected the code existed. But 1 in 5 runs, it proudly returned Unicode Escape v2, like it had just reinvented the wheel. So the lesson here is high temperatures make the AI creative but erratic. And then now when I'm generating tag names, I keep the temperature at 0. It's boring, but at least it doesn't surprise me with sequels. Providing context in your system prompt helps establish a solid foundation and improves the quality of your AI responses. Some examples are you're a web security expert, you're a security analysis, and you're a Python expert. I use the first for detecting vulnerabilities, the second for analyzing requests and making notes, and the last one for code generation. You can prevent indirect prompt injection by converting your data to JSON and then getting the AI to analyze the inline JSON instead of raw text. I've used this technique multiple times, and provided your system prompt isn't overly complex, this is really reliable way of communicating with the AI and preventing indirect prompt injection. So as I said, forcing the input into JSON helps prevent it from breaking out, making indirect prompt injection unlikely. So unless there's a JSON parsing vulnerability, for example. The trade-off is that AI will start referring to this JSON structure when describing the request. You can usually get around this with a bit of prompt tuning. Handling and escaping complex XSS payloads with quotes can become really tricky, especially with complex XSS payloads. For this second case study, I'm going to show you how I built Shadow Repeater. So in this video, I'm sending 3 requests with server-side template injection attacks. But I forget there's some Ruby syntax. My requests are monitored by Shadow Repeater, and it generates an AI variant that causes the application to behave differently. I'm dividing 1 by 0 because I want when the code is executed to cause an internal server error. So in this request, you can see that AI has identified that I missed the Ruby syntax. It's made the request in the background and then sends it to Organizer to let me know that this is an interesting finding. Remembering every possible attack vector is tedious. So imagine having a sidekick that watches you as you send the request, creates smart variants on the fly, and then alerts you when something interesting happens. This is exactly what Shadow Repeater does. It looks for differences in the request and gets the most frequently modified parameter to optimize what it sends to the AI. It analyzes the request as JSON to avoid the indirect prompt injection. It first creates a request key from the host and parameter names, and then uses a HTTP handler to monitor repeater traffic. It builds a request history for each key, and then performs request diffing and sends the parameter to the AI. The AI then generates a variant, and then the response diffing is used to determine if you were successful. So first we need to build the request key to identify the repeater tab you're trying to hack. The key is then used to group your requests for analysis. In the code, we use the current host combined with parameter names to produce the request key. So note, this is kind of a hack to identify the repeater tab. In future, we're going to make this easier in the Montoya API. So the trick is here, because there's no way to get like the repeater tab ID, you can use the parameters in the host and then only intercept repeater requests, and then you can identify all the requests for a particular attack that you're doing. Shadow Repeater uses a HTTP handler to intercept every repeater request and uses the request key to store all the requests in a list. After an arbitrary amount, the default is 5. It then uses the request differ and then gets the parameter that's changing, sends it to the variation analyzer, and the variation analyzer generates a variant. Here's a snippet of the prompt I use for the variation analyzer. One thing you really have to hammer home is that it should not output Markdown. It's completely obsessed with it. No matter how carefully you craft the prompt, it will still try to sneak in Markdown. But you can reduce its likelihood by reminding it repeatedly not to do it. I also explicitly tell it not to spoof domains. That's because I want it to use real domains already present in the input, like a collaborator domain, for example, rather than just making things up. Interestingly, it's surprisingly good at recognizing RFC patterns. It even understood an encoded word email address and produced a base64 variant, all without being explicitly told to, which is pretty impressive. So I don't know if you're aware of an email splitting attack, but you basically take an email address and split it in two, and then you hex encode the data on the left-hand side of the email address. The AI worked out I was doing that sort of an attack and then decided to generate a base64 variant. So it took the attack, constructed the email, and then created a base64 variant that did the same thing, which was pretty amazing. I issue multiple alphanumeric requests, allowing me to consistently pinpoint static and dynamic response attributes based on how the system responds. So here's the calculate fingerprint method, which what this does is look at the attributes in the diffing logic should consider, such as spaces, new lines, or error messages. This snippet of code, if the attributes differ, in this snippet of code, if the attributes differ, these differences will be flagged. So here we've got spaces, we've got error messages. So the idea here is you send your alphanumeric request and the AI's request, and if the AI causes one of these differences, it's flagged. So as I said, once all alphanumeric requests have been sent, and it's established what the interesting attributes are. The vector is sent, and if it causes an invariant attribute to change, it's flagged as a potential bug. The base request, the response, the interesting response with the vector, and the changing attributes are all sent to the organizer and stored within its notes. This allows you to detect even unknown vulnerabilities, provided the response is different. The more precise with your prompt, the better results you'll get and the fewer credits you'll burn through. The key is focusing on what actually matters for your task and cutting out the noise. Burp has a 128k token limit, so it's crucial to optimize what you send. If you're analyzing parameters in Repeater, focus on the differences and the most common modifications, similar to how Shadow Repeater works. Avoid sending full requests and responses whenever possible. If you do need to send them, make sure you truncate them to stay within the 128k token limit. A good example of this is, imagine you're testing for path traversal and you want the AI to analyze that. The first request you make returns a PNG file, which immediately takes you over the token limit. This is why you need to optimize and truncate. For this case study, I'm going to show you how I built Document My Pen Test. In this example, I'm conducting a path traversal attack. I click and execute Document My Pen Test, and it writes notes in Repeater with exactly what I've tried. After further testing, it notices that I've exploited the Academy Lab and updates the notes. So it's really boring writing up an attack you've just done. So the client wants to know what you've tested for, but what if you could do this automatically? This is what Document My Pen Test does. As you hack the target, it'll write the notes for you, taking the boring bits out of your test. And then after that, you can get it to write up a report. It uses a hybrid approach, either sending optimized segments of the request and response or the full data. When parameter modifications are detected, it uses a reflection-based prompt. Otherwise, it sends the entire request and response. Reflected data is optimized by replacing non-alphanumeric characters in the tested parameter with a regular expression, allowing it to detect transformations without a follow-up request. The notes will even highlight how the output is encoded. If the data exceeds a set threshold, the requests and responses are truncated. So in this example, we take all the non-alphanumeric characters out of the script alert payload and convert them to a regular expression, and then send that optimized segment to the AI, and that gives you better results. And not only that, when it generates the notes, it will actually tell you, you've done this, you've sent this request with this payload, and it was encoded like this. I add context to the prompt to help the AI understand what's expected. I supply requests and responses inline JSON, along with the dates to indicate when the test took place. This enables the AI to generate natural sounding sentences like, in the morning I was testing for XSS, followed by sea surf in the afternoon, as if you'd written it yourself. There are a few strategies for handling large responses in Document My Pen Test. The tool enforces limits on the response and image sizes to prevent issues like the images consuming all of your token budget, especially during tests like path traversal. You can adjust these limits in your settings, and then there's another approach you can use to detect if a response is a valid image, and then just skip it if it is. So what Document My Pen Test does, it has a separate setting for image sizes, and it just checks the size of the request and then skips it or just sends a chunk of it. So consider implementing a check if you're over your maximum token limit in your AI class, alongside a method to check if the AI is supported. This allows your extension to adapt its behavior when approaching the maximum token limit and detecting when the user has enabled the AI features. So you built your prompt, but the results aren't great, so now what? Well, you can get the AI to analyze its own response and ask follow-up questions why it thinks there is or isn't a vulnerability. And it'll walk you through its reasoning with detailed analysis. I did this for Document My Pen Test. So to improve my prompt, I started asking ChatGPT, look at this LLM response and explain why they think this XSS when there clearly isn't. It came back with a detailed breakdown of where the response was going wrong, and that helped me improve it. I kept the analysis going in the same session, and I gave it a prompt and asked how it could improve that prompt. It pointed out there was an issue in the ambiguity of my language, and there was a lack of clear rules for distinguishing what counts as a vulnerability. It was really helpful because it really improved the prompt and made Document My Pen Test more reliable. So you can use different prompts for different tasks. So, for example, detecting reflection-based vulnerabilities versus request smuggling. These require two distinct instructions. Reflection detection might involve comparing encodings, while the same prompt would confuse the AI when identifying request smuggling, leading to poor results. I prefer to write my prompts in a generic way, avoiding direct references to specific vulnerability classes. Instead, I design my prompts that can be applied across multiple scenarios. For example, when analyzing repeater requests, I look for clear parameter modifications. If they are present, I can use a reflection-based prompt. If not, I switch to a different prompt that can help with identifying issues like request smuggling. The advantage of using a generic prompt is that your extension will get better with time and improve and can be even more flexible in identifying vulnerabilities. You can also find unknown vulnerabilities too using a generic prompt. For the last case study, I'm going to show you how I built Repeater Strike. This extension is the most ambitious of my 4 extensions. It's currently under development and it's far from finished. In this demo, I'm using an Academy lab that contains an IDOR vulnerability. I begin by sending a single request and response to Repeater Strike. Next, I instruct the tool to generate a strike rule using the AI regular expression method. This step involves identifying the parameter under test, constructing the probes, and then generating regular expressions to match relevant parts of the response. Once the valid match is confirmed with the generated regular expression, the tool prompts me to save that rule. The AI then mutates the probes based on the original request and scans the proxy history for similar behavior. As a result, it successfully identifies both administrator and Carlos behaving the same way as the original request, indicating a logged-in state and revealing their API keys. All this was achieved using only 26 Burp AI credits. Importantly, once the check has been created, no additional credits are consumed. So Repeater Strike is an AI-powered tool that helps you uncover IDOR vulnerabilities and analyzing your repeater requests. It automatically generates targeted regular expressions based on your request and responses. And once a vulnerability is detected, these regular expressions are then applied to your whole proxy history. It lets you load multiple requests and responses for analysis. It uses AI to generate regular expressions to capture patterns across all your responses. So rather than relying on request diffing, this approach uses the AI to identify the specific parameter under test and the actual vulnerability. Once these are detected, we can then use that context for further probing for similar issues. The communication is done with the AI using inline JSON. Interestingly, no extra prompting is needed. The AI intuitively understands the square bracket structure to imply arrays, the pipes that suggest enums and value options. This likely comes from exposure to common patterns in TypeScript interfaces. It makes things a lot more efficient working with the AI. I found this very useful and very effective, and I really recommend the approach. So the problem you've got with an AI response is if you've got a type property and you've got a value of URL, for example, Sometimes it will give you an uppercase URL. Sometimes it will give you a lowercase URL. Sometimes it will uppercase the U at the start. So using like this type script / JSON based request, it immediately makes the AI consistent in its responses. So the type will always be URL, path, header, body, JSON. It's really cool and works really well for getting consistent responses. After analyzing the request, the AI recognized I was probing the ID parameter. It correctly identified the context as a URL parameter and inferred the vulnerability class was IDOR, insecure direct object reference. Once the AI has identified the vulnerability and the relevant parameter, I ask it to generate appropriate probes, mutated variants, and regular expressions. By including single comments as guidance, the AI instinctively infers the expected structure based on the examples provided. So here we give it a list of probes and it has like mutated properties. So it'll mutate the probes and it'll mutate the regular expressions, all based on what you've actually sent. This is how that looks like. So by applying a bit of prompt engineering, I was able to guide the AI to generate generic regular expressions. So to create a usable scan check, it requires multiple regular expressions. Once the initial check is validated, the AI can be prompted to mutate and update the regular expressions to align with the probes. So with a bit of prompt engineering, you can get it to generate a generic regular expression to match the API key rather than the exact API key. Then you can get a variant of the same thing. During development, I ran into several challenges. One of the most major issues was handling large responses. So while the AI could interpret smaller ones effectively, it struggled with larger responses like ones from Facebook. I initially truncated the data, but this led to important context being lost. Another hurdle was inconsistent output from the AI. So, for example, you tell it to generate a regular expression, but sometimes it would fail to escape meta characters, like in a JSON curly brace, for example. So a workaround was to programmatically escape these characters when an exception occurred. The broader concept proved difficult to generalize to. So while it could detect issues like IDOR on specific sites, it was difficult to create regular expressions flexible enough to work across different sites without being too site-specific. So I experimented with response diffing as a way to extract meaningful data by filtering out the noise, such as insignificant headers, and by focusing only on parts that change. In the end, I ran out of time to solve this, but maybe you can. Can you find an elegant solution to isolate meaningful UI changes and feed it to the AI? Give it a shot. Maybe you can do it. Ooh. In this section, I'll share some practical guidance on creating your own AI burp-powered extensions. You can scan this QR code to get the boilerplate code and access Portswigger's documentation. An important question to ask before you begin work on your AI extension is, can it be solved easily with code? If the answer is yes, then it's probably a poor choice for an extension. It's essential to use AI for the right kind of task. It excels at describing what code does, generating code or XSS variants, or keeping track of the steps you've taken during an assessment. But it struggles with anything that requires precision or deterministic logic, like regular expression pattern matching, sorting, or filtering. The boilerplate code is simple to get started. All you need to do is implement the enhanced capabilities method, and then your extension can use AI functionality using the Burp Montoya API. I strongly recommend building a dedicated AI helper class. This helps you handle token limits, temperature control, AI capability checks, and crucially, logging all AI requests and responses. This kind of logging is invaluable for auditing and debugging. It saved me a lot of time when I needed to truncate the requests and responses, and in one case, a customer asked for a complete audit trail of all AI interactions with Shadow Repeater. This was easy to provide thanks to this AI class. So always check if the AI is supported before making a request. Note that users can disable AI capabilities, so you need to check for that. You can use the system message and the system prompts from your helper class to assess token usage. Unfortunately, the system prompt also adds to your token limit, so you need to add both of them to make sure that you're under your token limit. Define a maximum level token limit that can be a class level token limit that can be updated when Portswigger raises the cap. If you store your system prompt and your user prompt, you can then check if it's over your maximum limit. Your execute method will allow you to log everything that's going to the AI and everything that you get back. This is useful for auditing purposes. In Shadow Repeater, I used a diffing strategy that focused on changing parameters to minimize noise. So when sending responses to the AI, consider trimming unnecessary content, especially in large responses like images, to keep things efficient and focused. The less you send to the AI, the faster your extension will perform. Always treat AI responses as untrusted input. Escape them if you're using them in HTML. Caching can be useful in certain cases. For example, in Hackverter, the AI tag output is cached to avoid excessive token usage, since the tag may re-execute on every keystroke. So you saw this with the hash example. Hackverter will prevent sending data to the AI because there's a cache implemented as well as a time that you've last sent that request. So as you press the keystroke, it can handle that and cache the data and then return it. You can even use AI without writing a full-blown extension. Burp now supports AI in custom actions. If you've not heard of custom actions, they're really cool. From next week, you can even get the AI to edit the request itself. So in this demo, I've built a hacking assistant using a custom action in Burp. The action runs a snippet of Java code that executes the AI prompt. From this custom action sidebar panel, I send the assistant a prompt instructing it to exploit the XSS vulnerability and then follow up again and telling it to URL encode it. So this is just you can create your own assistants within Burp in the custom actions panel, and then you can just fork this custom action and create your own. So yeah, it's pretty powerful. Here is the entire system prompt I used to do all that. You can fork this custom action and create your own assistant or different tasks or more advanced operations, all by just editing the prompt. So only that system prompt, and then I'm using Swing's input dialog to get input from the user. It then executes this custom action with the system prompt, and that allows it to edit the request. So you'll notice I return a JSON object. I just tell the AI, if the user wants to modify the request, just return this object with the modified request. It's gone off. What's going on? Oh, here we go. So AI has come a long way. It's really surprised me. I wrote these extensions quite a long time ago, some of them, and the models have improved extensively compared to just a year ago. Back then, you added detail to the prompt. It often made the output worse. Now it does the exact opposite. While working on Shadow Repeater, there were moments that genuinely shocked me, like when the AI took a Q-encoded email address and generated a base64 variant without being explicitly told to. The pace of progress is staggering. If you want to stay ahead, integrating AI into your workflow isn't optional, it's essential. Before I wrap up, here are 3 essential key takeaways to keep in mind when working with AI. Always optimize what you send to the AI. Never blindly trust what it gives you back. And most importantly, learn when it actually adds value. If you want to see this in action, just check out my AI-powered extensions, Hackverter, Shadow Repeater, and Document My Pen Test. They're all available on the BAP store, ready for you to install and explore. Repeater Strike will be available next week if you want to check it out. You can get all the source code using that QR code. Don't forget to follow me on the site formerly known as Twitter. And if you like insane 3D websites written without JavaScript, check out my website, garethhayes.co.uk. My colleague Zach is also doing a talk on track 2 at 4:30, I think, on cookie chaos. It's absolutely fantastic, so check it out. Thanks for listening. Any questions? Sure. Yeah. We're not. Sorry. Oh, okay, yeah. So the question was, can you use other models like a local model to execute to the AI? Currently, we don't support that. There has been requests for it, and we are considering the request, but yeah. Yeah. Match and replace. So you could use a custom action to modify the request and responses and use AI in that way. We don't. There's a 128k token limit at the minute. Yeah. No, it won't work, no.
Have you worked on anything that can actually modify the response?
So, have I worked on something that modifies the response with AI? Is that the question? So no, because of the amount of data. So I've generally focused on requests. That's why I was showing with Shadow Repeater, you have to analyze the differences. And then get the most frequently modified parameter and just send that optimized thing to the AI. That's why I've been taking that approach, because of the token limit. Yeah.
Let's say I want to file a SQL injection and request. Then how does it work better than running SQL?
So it'll work better because you're supplying the request with information. So like, you might be aware that there might be specific filtering on the endpoint, and then you provide that filtering, and the AI will reuse that filtering. So like, it knows something is filtered, for example, and when you send something, it'll learn from that. Does that make sense? So like, your repeater requests are being sent to the AI, and the AI is learning what you're sending. So, yes, you can run SQL map, but using the repeater, providing targeted modifications will generally help you bypass restrictions such as filtering on the site.
Then would have been able to learn some case-based requests and then learn some pattern data, and then discover some new table that
Yeah, exactly. That's exactly the point. You can even write an extension to pipe the information to SQL map if you wanted. So like you could say for example, you've learned that there's a specific encoding on the site, then you could do that encoding and pass it to the extension at the end, and just run SQL map. Any questions? Yeah.
So a quick question. So what you just showed here,
Yeah.
it's heavily focused on creating extensions using Java, and essentially entirety. But is there a possibility to use an API and not be sort of pigeonholed into the Burp way of doing things?
Well, my extension was to celebrate the functions in Burp. Yeah, there's no way to use another model at the minute.
I can't remember which GitHub repo it was, but there was one from a big company that created an API for Burp. So using that kind of API usage, would you be able to take the information from Burp within there and then use it like Root or Alarm to then take that information, do the process, and then send it back to Burp? That's something you've had the experience with, or you've mainly been focusing on the extension side?
Yeah, I've mainly been focusing on extensions. So my main focus is to augment what you're doing in Repeater. That's what I want to focus on, because I think that's an area where you can provide, not only like provide information to the AI, but get the AI to do hard like work in the background for you. So yeah, I've not really focused on other things other than what I've demonstrated today. Cool. Thanks.